Our team is presenting an Arduino based radar system, a project designed to detect and map nearby objects. This system integrates hardware and software to emulate basic radar functionality. Its simplicity and adaptability make it ideal for learning about electronics and exploring real world applications, including robotics, home security, and smart systems. So, let's take you through the details. This presentation is organized into 5 key sections. So basically that include the first is an introduction to the radar system outlining its purpose and components. Second is a list of materials used in the project. Third is the connections required to assemble the system. Fourth is an explanation of how it functions. And fifth is future applications and potential for further development. So let's start with the introduction. Our radar system uses Arduino technology to create a compact and efficient object detection and mapping tool. The purpose of this project is basically to explore the basics of radar technology in an accessible way while also demonstrating its potential applications. The system includes an Arduino microcontroller for control, an ultrasonic sensor for distance measurement, and a servo motor to rotate the sensor for scanning. This setup allows for flexibility, making it applicable to projects like obstacle detection in robotics or security systems for monitoring restricted areas. Next up is bill of materials. So to build this radar system, we have used the following components. Uh, the first is Arduino Uno, which serves as the main controller. Then HC-SR04 ultrasonic sensor, which is used to measure distances by emitting and receiving sound waves. Then SG90 micro servo motor, which enables sensor rotation to cover a wider area. And additional components include breadboard, jumper wires, resistors, and a USB cable for programming and powering the system. These materials are cost effective and widely available, making the project accessible for learners and enthusiasts.
Let's first look at the connections of our radar system. Starting with the servo motor, its power wire is connected to the 5-volt pin on the Arduino to provide the necessary voltage, while the ground wire goes to the ground pin to complete the circuit. The signal wire is connected to digital pin 12, allowing the Arduino to send PWM signals and controls the servo's motion. For the ultrasonic sensor, the VCC pin is connected to the Arduino's 5-volt pin, and the ground pin goes to the Arduino's ground for a stable power supply. The trigger pin, which triggers sound waves, connects to digital pin 10, while the echo pin, which receives the reflected signal, is connected to pin 11. These connections enable accurate distance measurement. Each component works seamlessly when powered and grounded properly, enabling smooth communication with the Arduino. Now moving to the explanation, the ultrasonic sensor emits sound waves at 40 kHz. These waves travel through air, bounce off objects, and return to the sensor. The Arduino calculates the time it takes for the waves to return and converts it into distance using the formula distance equals to speed of sound into time divided by 2. Meanwhile, the servo motor sweeps the sensor across a wide area, collecting data from multiple angles. This creates a comprehensive view of nearby objects. The data is sent to processing software via serial communication. This software visually represents the scan data as a radar display, making it easy to interpret object positions and distance.
Hello everyone, I would like to continue the presentation by future scope and applications of radar and sonar systems. By incorporating advanced sensors such as LiDAR, that is light detection and ranging, or infrared sensors, the radar system can achieve greater range and accuracy. Those sensors provide us higher precision in object detection and can function effectively in various environmental conditions, allowing the system to be used in more demanding applications such as autonomous vehicles and industrial automation. Implementing real-time object tracking algorithms can significantly enhance the interaction capabilities of the radar system. With artificial intelligence and machine learning techniques applied to the collected distance data, the system could identify and follow the moving objects, thus opening possibilities for surveillance, robotics, and smart home automation projects. Integrating this radar system with robotics can facilitate intelligent navigation solutions. By occupying and equipping robots with these systems, they could autonomously detect and avoid obstacles, and navigate complex environments as well, and improve interaction with their surrounding, making them suitable for use in various places like warehouses, hospitals, or homes. These radar systems also serve as an hands-on project for students and hobbyists interested in electronics, programming, and robotics. It introduces key concepts such as sensors integration, data processing, and real-time visualization, while encouraging experimentation and learning through project modifications. This system can be adapted by IoT applications, enabling remote monitoring of environment. By sending data to a cloud service, user can access real-time information around and about the surroundings from anywhere, enhancing security, smart city analytics, or environmental monitoring. Future enhancements might include wireless communication features, allowing for easier integration with smart devices or smartphones. This capability would enable users to interact with radar system through mobile applications, receive notifications about detected objects, or control the system remotely. So I would like to conclude the presentation about the project which we have made using Arduino Uno. The Arduino based radar system provides us a fundamental and foundational understanding of radar mapping and obstacle detection using a combination of hardware and software, with significant opportunities for future enhancements and application. So we have learned a lot in this project about hardware and software, and how we could integrate software into hardware implementation as well. And we have learned a lot about radar and sonar, that is radio detection and ranging, and sound navigation and ranging, using Arduino Uno. Thank you. And we have used references as well, which will be shown at the end of the presentation.